Good morning, everybody.
Good morning.
All right, that was enough excitement. My name is Anita Zhang. I'm an Engineer D, Manager D at Meta. That's just a fancy way of saying I'm a software engineering manager for the Linux umbrella family of teams. And today I'm going to talk about adventures of Linux Userspace at Meta. So if you've been to one of these talks, maybe in prior ASGs, we usually did a systemd at Facebook update. This is going to be really similar, but we've expanded beyond just systemd. So there's a lot of different projects that I'm going to go over and some of the stuff that we did in the past 4 years since we last did one of these talks. And because I don't think we've ever actually talked about what is Linux Userspace at Meta, I'm just going to give a brief overview of the team and what we actually do here. So let's get started. What is Linux Userspace at Meta? So it all started with the Linux kernel team at Meta. It was primarily a group of kernel maintainers that we kind of hired up to work on the Linux kernel upstream. The idea here is that by being upstream first, we can have a smaller team that works with the open source community and tackle problems beyond what we have capabilities for in-house. We used to have an operating systems team at Meta, which was very similar to what we still do on Linux Userspace today. They focused on contributing upstream, doing community building work. They worked on all kinds of stuff, from like Chef, CentOS, systemd, upstream packaging, and whatnot. Eventually, that was like split off into like a bunch of other different teams at Meta with less of an open source focus, but we kind of keep the spirit of that alive in the Linux Userspace team. So today, Linux Userspace team still continues to work on Linux distributions, community building, packaging, and of course, we also make quite a few contributions to systemd, and more recently, we've started partnering with the BPF kernel team to do BPF enhancements in the Userspace area. Because a lot of what we talk about probably wouldn't make sense unless you understand our fleet a little bit, I want to bring up that we now have millions of hosts at Meta. It is largely homogeneous, but we are starting to see an increase in hardware diversity due to all like the AI stuff. For the most part, teams maintain their own set of bare metal hosts, but we do have a large pool of hosts dedicated to running containerized services for anyone who just wants to run a service without maintaining their own hosts. And we also support a bunch of services on bare metal directly itself. Right now, we are in the middle of upgrading from CentOS Stream 8 to CentOS Stream 9. I say middle, but we're like over 90% of the way there at this point. And it's worth pointing out that systemd is one of the few packages that we stick pretty closely to the upstream releases. So I wanted to say that I'm like done with the systemd 253 update at this point, but we hit an issue. So now we're rolling back. We're going to restart this after this talk, I guess. If you want to hear more about how we roll out systemd, Dawn and I actually did a talk at the CentOS Dojo in August 2022, and you can read more about that on your own time. I forgot to mention, all the slide deck should be on the website already. This talk is more breadth than depth. So if you wanted to go deeper into any of the topics, I included a bunch of links throughout the slides that you can look into on your own time. Okay, so recapping some of the work that we've done in systemd in the past few years. By the way, this is all just like a subset of the stuff we work on. Yesterday, Content had a talk on BP filter, and today Dawn has like 2 talks on makeOSI and systemd repart. So a lot of that stuff's not going to be covered in here. I'm just going to go over some of my favorite projects. So systemd UMD. At the end of the last All Systems Go in 2019, we talked about integrating FB UMD into systemd. So if you're not aware, UMD is a user space out of memory killer. It uses C groups to pressure stall information and more to kind of do more fine-grained killing in user space versus the kernel killer, which is a bit less flexible in the policy. This spun out of the FB UMD project, and I did a technical deep dive on it at Linux Plumbers in 2021. When systemd UMD was merged in systemd, we actually worked on getting it enabled by default for Fedora 34. There were a lot of tweaks since then to make the defaults more reasonable. I think, you know, love it or hate it, you probably had UMD kill your desktop environment at some point. That is one of the quirks with systemd UMD, is that it does rely on your desktop and browsers to kind of split processes off into the correct C group, which GNOME does pretty nicely. We worked pretty closely with the open source community to get that ironed out and kind of make the defaults kind of usable to what they are now with the desktop environment. And then systemd UMD at Meta. So as of right now, we do roll out systemd UMD alongside the original FB UMD at Meta. There are a few cases that FB UMD handles that are not yet or may never be upstreamed in systemd UMD, depending on how our internal experiments go. So SunPy is one of the plugins that we have in FB UMD. Johannes did a talk on this at AHG 2019, but SunPy is an automatic memory resizer, and it makes use of memory.reclaim in the kernel to kind of resize the resource control settings on the fly. And one of the other quirky things that we do at Facebook is we're trying out memory profiling before an UMD kill. That hasn't proven to be like super useful just yet, so we're kind of waiting to decide whether to add like pre-kill actions to systemd UMD. Okay, systemd networkd. This has been shipped with systemd for a long time now. It allows you to configure network configurations in a systemd style set of files. It's notable that up until CentOS Stream 9, we were actually still running network scripts at Meta. I know, very shameful, but because network scripts were deprecated in RHEL 8, and you know, for a fleet our size, you don't really want to be managing your network with bash scripts. So for the CentOS Stream 9 upgrade, we decided to go all in on migrating everything to systemd networkd. And I did mention before that that rollout has actually reached over 90% of the bare metal fleet, so over 90% of our fleet is now running our, managing our network with systemd networkd. I think it's cool to note that big, scary migrations bring people together. A lot of engineers at Meta internally were motivated to do this safely. And the benefits of systemd networkd is that now there's like a lot of random teams coming out of the woodwork to say like, hey, can we like do this cool thing with networkd? Can we like, I don't know, add this feature or like migrate more things that they used to do manually to a networkd configuration. And the systemd maintainers were like super supportive here as well. Big shout out to you, Watanabe, for helping with all my issues and things like that. Okay, systemd journald. If you use systemd, you probably already know that this exists. It collects and stores logging data. Our work on systemd journald was motivated by the question of, can we stop using rsyslog? Internally, we still forward all our journal logs to rsyslog for log management. And kind of the two big reasons there were the journal file sizes and also the reliability of journald. So those are some of the things we tackled first and resulted in the journal compact mode, which is a new, I don't know, like feature, or it's another flag to optimize the systemd journal sizes. And also Don worked on a few different issues or a few different fixes related to making the Btrfs compression work better because the majority of our fleet is Btrfs. And along the way, there were also like multiple improvements upstream in how journal file corruption and also the daemon itself. If you're interested in this, Don did a talk at Plumbers 2022 about his work on the journal. Okay, now I'm going to start getting into some of the work we've done on distributions, starting with the hyperscale SIG. So the Hyperscale SIG is a special interest group that was formed in 2021. And our focus here was to enable CentOS Stream on large-scale infrastructures. But we do want more bleeding-edge features, and that's kind of what the Hyperscale SIG is for. So I mentioned that we stick pretty closely to systemd upstream. We base most of the packaging on Fedora Rawhide, and actually all the RPMs that we build for our fleet, related to systemd, are available through the Hyperscale SIG. We also have the Hyperscale Intel repository, which has optimized packages that hyperscalers might enjoy. And we also use it as an opportunity to experiment with ecosystem changes such as like RPM copy on write. And if there are any like alternative policy changes, we also try those out in the Hyperscale SIG. A lot of like infra and automation work was done to like make this as like easy and painless as possible. So you should be able to, pretty much anyone can contribute and like try out the stuff that we deploy in the Hyperscale SIG. Okay, now I'm going to talk about Fedora Asahi Remix. So if you're not familiar, Asahi Linux is a project that aims to bring a polished Linux experience to Apple Silicon Macs. And this is pretty desirable because then you can have a high-performance, reliable, like pretty readily available ARC64 platform. The Fedora Asahi Remix is the flagship distribution for Asahi Linux. And this was like over a year of collaboration between like multiple open source projects and developers to get this, into a state where anyone can use it. I think the beautiful part about this is that it kind of brings together all kinds of people who are just super motivated by a project to, ship something great together, make use of the talent that we have available. All right, and now I'm going to talk about the last of the distribution changes is frame pointers. So frame pointers was a change proposal for Fedora 38. If you're not familiar, frame pointers just stores the position of the last stack frame in a register. And what that allows you to do is it makes it much easier to unwind the stack. So you want this for like debugging, profiling, tracing. For the most part, frame pointers are not compiled in by default. And you do this because you can net some like performance optimizations and things by being able to use the register for something else. But it makes it really inconvenient for like debugging, profiling, tracing if you don't have it. So in order to kind of work with the community to get this change proposal accepted, there were a lot of benchmarking and alternative explorations into the space. So as of right now, the frame pointers are conditionally enabled by default, starting in Fedora 38. Special shout out to Zbigcheck over there who helped a lot with the, kind of like the PR and the Fedora side. But we also had like a lot of technical people come out the woodwork in favor of this. So for ARC64, they already had frame pointers, so this was like kind of a no-op. We did omit a few architectures so that we can do some more testing and benchmarking. And then I think it's notable that we had to opt out in Python 3.11 due to some benchmarking regressions. But Python 3.12, in perf, the tool, you can actually get like Python stack traces and stuff, so they do actually recommend enabling frame pointers for 3.12. And in theory, there should be like optimization, speed ups and things in Python 3.12 that could offset or even fix the regression we saw before. Not sure if that has actually landed yet. I'd have to check on it later. I included a quote here, which Andre wrote on Don's status report to show, like, why did we start working on frame pointers in the first place? Well, it's because like Don was complaining about how he had pretty bad stack traces for systemd. And Andre noted that, oh, like, are we missing frame pointers? Because I think the stack traces in Strobe Light, which is our internal continuous profiler, they're like not that great. And that kind of just spun off all of the work that we've done to propose the change in Fedora. Also notable, like, not everything is planned. We do a lot of unplanned work here. Okay, so now I'm going to close this with some of the new stuff that we're doing in Applied BPF. So Applied BPF is a collaboration between the Linux Userspace team and the Linux kernel BPF team at Meta to kind of work on the application side of BPF and making things more accessible for the community. So currently, we've started working on systemd BPFD, BPF tokens. We're going to be moving into making SCEDX more useful, and we're going to expand on BPF trace. I'm going to talk about the first three in a bit more detail and omit BPF trace for now because we're still planning out that space. So systemd BPFD. The original motivation around this is we wanted to figure out how to better manage BPF programs, particularly when you attach them. How do we get the ordering right? How do we get more visibility into BPF programs and things like that? How do we support like unprivileged access? Originally, we were like thinking, oh, maybe we can put all that in BPFD. But it turns out that's like a pretty tall order. And actually, with more design work, we figured out that it would be better to actually just split out some of these features into the kernel. So the initial version of systemd BPFD that we're working on right now just focuses on monitoring and auditing of BPF programs. And we're just going to start working on like the visibility of BPF as it relates to systemd first. So one of the things that spun out from BPFD was BPF tokens. So this is something Andre's been working on to allow BPF to be used inside user namespaces. Because one of the issues that we have right now is that containers with user namespaces, they can't actually use BPF because you would need additional capabilities on top of like just cat BPF in order to properly trace things. So the idea behind BPF tokens is that you could delegate the permission from a trusted process, such as the container manager, into the container. And once this is merged, which is still like going through a few revisions, we plan to add this into systemd and like other projects. And then last one I'm going to talk about is SCEDX. So SCEDX is a framework for implementing Linux schedulers in BPF in Userspace. So this is something the kernel team at Meta has been working on with a bunch of other maintainers across the kernel community. And you want to do this because even just like the most basic BPF scheduler is starting to show like pretty significant performance wins. And we want other people to be able to reproduce this while we're still experimenting with getting this merged in the upstream kernel. So some of the things that we plan to work on in the applied BPF space is to just make SCEDX more usable for like, the general audience that's like not a kernel maintainer at Meta. Okay, so we wouldn't be the Linux Userspace team without the people behind it. So this is what our current roster looks like. Thanks for listening to my talk, and if you have questions, we got 5 minutes to do it. Yes, sweet tea.
So you mentioned that the fleet at Meta is getting more heterogeneous with the AI stuff. Has the AI stuff had any interesting systemd work come out of it?
Me churning whether I am allowed to say or not say things. Not explicitly right now. I'd say probably the SCEDX stuff has potential for spinning off some more work there. But in AI, I actually support a couple other teams, so that it's the non-open source side of things that it affects more.
So with the fno-omit frame pointer stuff, do we have some significant performance gains that we realized based on this?
Not yet. So one of the things that we talked about after we got frame pointers merged is more general purpose profiling. And so one of the things we discussed is whether we could open source parts of strobe light, or we worked with polar signals on how we can get like more tracing visibility. I don't think we have anything notable yet, unless Davide knows something I don't.
We had a few folks on the community side that reported that they were able to leverage this feature to apply optimizations. I remember there was a blog post from a GNOME developer, for example. It's kind of hard to point to specific things because it's one of those things that like it's just there and people can use it, but they may not make the connection that the reason they were able to debug something and fix things was because of this change, because it's just there. And if you don't have frame pointers, you try to debug stuff, your stack traces will suck. But if they don't suck, you probably won't think about it too much. So it's a bit hard to connect. My understanding from looking at, I think there was some benchmarking data that was released about 6 months or so ago, was that these, they were worried initially that enabling frame pointers in Fedora would lead to performance regression, and there wasn't a measurable regression, and performance was actually better in some areas, but that's obviously, it can be due to other things in the distribution. But we can definitely say that this didn't make things worse, which was one of the main worries when the change was being discussed.
Given you've got so many systems running systemd, have you got a favorite edge case bug that's come up?
Well, we actually have so if you watch the talk, we actually talked about a bunch of bugs that we caught internally. My favorite bug is always the latest one. So the one that blocked the rollout yesterday, thanks Edge team over here who caught it. It was actually František, who works on the systemd CI, actually caught it a while ago. So there was an issue where we're using raw clone, and it conflicts with how glibc malloc locks work, and it was causing systemd a deadlock, and we were starting to see it at 7 out of 1,000 hosts. So that's one. Actually, one of my favorite ones is the systemd journald memory regression. I actually did a talk on this at another conference 2 years ago. That was pretty gnarly to debug. Kind of sucked too, because I was the only systemd maintainer at Facebook at the time. So. All right. Thanks, everyone. You're welcome to talk to me about anything else here.